Right. All right, let's do it. So, assignment 1, due at the end of the week. How's assignment 1 going? Finished? Ooh, good. How many people are done? How many people are close to done? How many people have not started? That's okay. Just, understand that we have a late days policy that doesn't exist anymore. We have a per diem deduction for each day that you're late. Now, that's the new policy in this course. So, if you like marks, get it in on time, please. Yes. Yeah. I'd like to introduce assignment. Well, I can't. Okay. All right. We need to get our butts moving on files. So, I'll publish assignment 2. You'll notice assignment 4 is still TBA. It's okay. It'll be ready before you are. Don't worry. Question.
I was just wondering, is it the shop answer?
It is, yes. Yeah. Well, thank you. Thank you for that endorsement.
Well, I told you I really enjoyed that one last time.
Yeah, I mean, so assignment 2. I'll introduce it at this point, or at least I'll give you a quick rough overview, the direction things are heading. This assignment revolves around files, right? We are going to be studying file input-output in reasonably short order. This assignment requires it. So the overall thrust of the assignment is to make the worst part of any video game in terms of programming an inventory system. I have a working example which is available for you to play with on CS Unix. This is like my instructor solution PHP scripts behind this thing, which you can't see because it's PHP and there's no way for you to directly query the PHP. This is why I can just give you like a live copy of the thing, whereas like in client side we couldn't do that, because to give you a live copy of it is to give you the JavaScript you were supposed to be writing, right? But anyway, so there you go. You've got your inventory at the bottom, right? You've got a couple of different shops, right? This is like one of my early attempts at playing with AI image generation. So like basically, you have a certain amount of gold. If you want to purchase leather armor, genuine Italian leather, made from cows, not Italians, then you buy, there you go. It shows up in your inventory. There are tables that you have to reference to determine what the buy and sell price is for different items in different shops. So for example, if I'm selling the copper dagger to this young lady, she'll pay me 17 gold for it. If I take the same item to the dwarf is much more impressed with the craftsmanship, and therefore pays you 80 for the same item, right? All of this is being looked up in tables on the server, right? And then if you talk to the goblin, he is very unimpressed with the copper dagger. He'll only give you 4 for it. There's a lot of like, there's like a CSV file that you have to read to get what item is how much in which shop, basically. So yeah, that's kind of like the rough overview. There's, the inventories themselves are JSON. They're JSON encoded. The that table I was talking about is CSV. So you'll be exercising both CSV and JSON file types for this assignment. And I tried to make the item descriptions humorous, so enjoy that. Also, I'd just like to point out that right there. All right? Let me blow that up so you can see it. That's right. So, lurking in the goblin's shop is a nasty little trick because he's a nasty little goblin. One of the item descriptions are also stored in files on the server. One of the item description contains what's called a stored cross-site scripting attack. I mean, it's not really an attack because all I'm doing is making a little alert box pop up, right? But if you fail to sanitize your inputs, that will execute as JavaScript, and a lot of browsers won't actually show the pop-up anymore, but I will know if you haven't done it properly by reading the text of this box, basically. If I don't see any text here, I'll know it's been, you haven't filtered it out and it's been included as HTML, even if it didn't run the HTML, right? If the script tags are missing but this is all still there, I'll know you're using sanitized string instead of some sanitized special characters like you're supposed to. And if you see what you see here, you've done it correctly because this is the instructor solution. Right? Make sense? So, any questions? I'll go through this again and sort of go through the text of the assignment after we've learned a little bit more about what it means to do files. Okay? All good? All right. I enjoyed putting this one together. I hope you guys enjoy it too. I know it's weird to say I hope you enjoy this assignment, but I do. I actually genuinely do and hope that you guys enjoy the assignments. So, all right. So let's talk about, am I recording? I hope I'm recording. Yes, I am recording. Okay, good. Sorry. If I'm a little bit scatterbrained today, I didn't get a whole heck of a lot of sleep last night because the baby has teething. Yeah, he's not even a baby anymore, he's a toddler, but he's cutting teeth, so I got my longest segment of contiguous sleep was 2.5 hours, and usually what tiredness manifests in me is just an increased degree of scatterbrainedness, so that's what you're in for today. That was also a very scatterbrained way to describe that. So, files. Shall we talk about files? What is a file? Somebody give me a technical definition of a file. Anybody? Yes.
It is a data structure where data is stored within.
A data structure where data is stored. What was the end of that sentence? Within? Well, yes.
Well, not necessarily a folder which would contain files.
Well, it's interesting because folders are actually files in Unix land, right? Files and folders are the same thing in Unix/Linux. It's just a directory has the directory flag set. So, but they're like the same kind of unit of memory. So, Anybody else got one? What's a file? I've heard it said of people who grew up using the phones that you guys don't even necessarily know what file and folder structures even look like because you do all of your computing with phones, and the phones do their level best to try to hide the existence of a file system from you. That's like one of the things they've abstracted out. I don't know how true that is. It probably was true of like 2 people and then became a legend, right? All right. To understand a file, we must understand things at the level of the hardware organization of the computer. Your description wasn't great, but that's okay. It was true, yeah, anyway. So, what are the components of a computer? We've got the CPU, that does processing. We've got 2 main memory systems. Can anybody tell me what they are? RAM and ROM, that's right. Can anybody tell me what RAM stands for?
Random access memory.
Random access memory. Can anybody tell me what ROM stands for? Read-only memory. What is RAM used for? Computations, sure.
Storing temporary information.
Storing temporary information. The RAM is the memory space which is actively used by programs. Anytime you've loaded Sid Meier's Civilization 3 onto your computer, the program that constitutes that game is loaded into RAM. That's, when a program, or a video game in particular, has the little loading icon in the bottom corner. Have you ever wondered what it's loading into what? Right? What does it mean for it to be loading? Well, what it's essentially doing is it's dumping data from the permanent storage, from the ROM, into RAM, because RAM is fast enough to be worked with. ROM is not fast enough for a program to really actively work with, right? It's temporary storage versus deep storage, right? Even under modern conditions where we are no longer primarily using magnetic disk drives, which were quite a bit slower than SSDs, like even in the era of SSDs, it's not faster than your RAM, right? RAM is still much faster than ROM. And register memory in the CPU is fastest of all, but you get very, 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 very little of it. And certainly not enough to store a whole program, unless it was an extremely short program. So, how do we organize the data stored in ROM? This is the question. During the development of the Unix operating system in the 1960s, it was determined for all time that the way that you organize the hard disk is into a series of directories and files. A file is a region of memory in permanent memory storage dedicated to some artifact of data. Right? That's what a file is. It's a region of the hard disk that we have given a label that we store data in. Does that make sense? Good? Robust definition of a file? Question?
This is more of an anecdote. I
Sure.
remember seeing a pretty funny video from a couple of years ago where someone formatted their GPU's RAM as a virtual disk, and then installed Crysis on it, and then ran Crysis, and then they restarted their PC and it was gone because it was RAM.
Yes, yeah, absolutely. I mean, you can trick the, you can certainly trick the computer into thinking that your RAM is your ROM, right? You could put a boot sector on it, sure, but like, the thing about RAM is that it doesn't survive a power cycle, so anything you put in there is gone when you're done. So, you know, let's just say, good for a YouTube video, but I wouldn't do that for a long-term solution for anything, right? So when we talk about files in the context of a server, right? We have already been working with files on the server, obviously. Our HTML files, our JavaScript files, our CSS files, and our PHP files are all files, all stored on the computer. The thing that we are now concerned with, how can we interact with other sorts of files, right? And what is the purpose of doing so? Well, when you have a file, it is shared data storage between everyone who connects to that server. That's the way to think about it, right? When you store a file on the server, the means of access that you give one person to it is shared by other people. It's a way of sharing data with all users, right? Sessions are a way of sharing data with one user. Databases are a complicated way of doing both of those things at the same time, right? So, let me show you a little example. This is an example program that I whipped up a little while ago now, but I think you should still, it still would be instructive. If I can remember where the bloody thing is. See you next time. Slash. Put it in Ajax? No. Oh, this is unfortunate. I'm going to have to look it up. Winter 2023? Yeah, there we go. So, this is Honor System Tic-Tac-Toe. If you, all of you in the room, notepad, please go to this URL, and you will be able to play Honor System Tic-Tac-Toe. So why is this Honor System Tic-Tac-Toe? Well, somebody just found out. It's because, basically, everybody who is currently logged, see, no honor. Everybody who is currently accessing this URL has access to the same set of PHP scripts, which are all sharing one file that stores the state of a tic-tac-toe game. Therefore, anybody who sends a move, right? Anybody who sends a move gets that move played. Now, it's Honor System Tic-Tac-Toe because, like, the number of rules that are implemented is just very small. Basically, the only rule that's been implemented here is you can't put a symbol into a spot occupied by another symbol. That's it. So yeah, like someone's just hammering reset right now, right? And yeah, it's extremely frustrating unless that's what you're going for. Unless you're trying to get it despite the fact that someone's hammering reset. But yeah, so in this case, everybody who's currently playing with this is accessing one file on the server, right? So this is like the kind of the kind of functionality that you can achieve. Like, it wouldn't be very difficult to take an example like this and extend it into something like a graffiti wall, right? A graffiti wall application where, you know, if I did the boxes as SVG rectangles each with a certain color and gave you the ability to, like, you know, click to drag to paint, right? Then you would have, you know, a picture that everybody could draw on at the same time, right? Something like that. But yeah, if you're interested in how this is actually working, right? If we take a look at the network tab, basically what it's doing, it's a lot of AJAX. That's how it's doing it. It's with a lot of AJAX. Essentially, I think every half second, this page triggers an AJAX request to the server, which requests the current state of the game, right? So the state of the board for me gets updated every half second, right? It runs into some interesting little concurrency edge cases because it works this way. But yeah, if I, for example, were to reset the game, you'll see that that was a call to reset.php, which basically reinitializes the file to be all blank squares, right? You guys want to see the PHP scripts? They're pretty simple. Gonna have to, like, log in though. There we go. So, if I go into my this one, there we go. So, let's take a look first of all at reset.php. So you can see this is pretty small, right? Well, I mean, you can see it's also pretty small in the sense that you can't see it because it's very small. But the script itself is not very long, that's what I was trying to say. There you go. So, I've got a file name, tic-tac-toe.data. I open the file, new contents, a bunch of ends, 9 ends, all on different lines, separated by the new line character. I then write the new contents to the file handle, close the file, and then send a message saying that the game was successfully reset. I believe on the client side that gets turned into a JavaScript console message. Yeah. So, let's take a look at tic-tac-toe move.data. There we go. So you can see right now that's the state when I pulled it. You can see that's constantly changing. So if I go back and I close this file and I ask to see it again, you know, it's now it's different, right? This is the active memory that's being shared by all of the users who are currently using the tic-tac-toe game. Make sense? Any questions about this so far? We'll go through in detail how to, like, what the function names are for all of this stuff. Okay? Good? Yes? Yes, yes, yes? Good, good, good. Thumbs up? Good. So, game state is pretty easy. Literally all it's doing, rather than rather than writing results into the file, we're still opening the file, but we are getting CSV lines out of the file, pushing them into an array, closing the file, and then JSON encoding that, sending it out to the client. Does that make sense? Now, it's certainly possible that I could have stored this data in JSON to begin with, right? That could have been one thing that I do. Since I'm sending it to the client as JSON, it kind of makes sense. However, like, whenever you're dealing with data that's kind of natively rectangular, if that makes sense, I always find myself defaulting to a CSV file. It just like makes the file simpler, you have fewer braces going on, everything like that. So, yes. Any questions? Yes?
Basically, you have like two PHP files, one that updates the new state of the web, and the other one that updates for all everyone.
So I have 3 PHP scripts. One performs the reset.
Okay.
The one I haven't shown you yet sends a move, right? So when you click on a square to put an X there, that activates the send move PHP script, which performs a more precise modification of the file. The only purpose of this one is to read the contents of the file and send that to the client so it can be displayed. Does that make sense?
Like basically, you have one that sends the modifications, and the other one that updates everyone's computer to the new state of the file.
Yeah, I've got
And
one
the
read.
second one, yeah.
I've got one read script and 2 write scripts. One of the write scripts writes one value, the other is a reset, which resets all of them. Make sense?
Yes.
Good. Cool. So, undefined. Whoa. Did you see that? That was quick. Yes.
What happens if you like don't include the dot data for the file? Does it break the script?
Well, I mean, the script seems to be currently breaking right now. So, you mean here?
Yeah.
So, I mean, if I were to perform that modification right now, if I were to modify the script so that I removed the .data file extension, it would break the script, but only because I don't have a data file called tic-tac-toe with no file extension on the server. Right? This string just purely and simply represents the file name of the file you want to access on the server. If I wanted to make a tic-tac-toe .txt, sure. If I wanted to call it Dr. Moore is the best awesome person, most awesome person, and then nobody has ever been better than him at tic-tac-toe, .data. I could call it that, right? File names are completely arbitrary. If I could call it, I could call it savedata.tic-tac-toe, right? File extensions don't really exist, right? File extensions only exist insofar as programs use them to determine whether or not a file is in the correct format, though there's nothing requiring a file with a file extension to be in the format represented by that file extension. It's just a label, right? So they exist, but they don't have any substance, right? Like, I can take a PNG file, I can rename it as a .xlsx file. Doesn't make it a spreadsheet, right? All I have is a PNG file with the wrong file extension, right? But yeah, you can make up your own file extensions, right? It's not like there's like, it's not like, as a programmer, if you want to make a new file extension, there's a mountain that you have to climb in California, where at the top of, it's just on the outskirts of Silicon Valley. If you climb up this mountain, then there is an old man with a very long white beard and a large book in front of him, which is the Book of File Extensions. And you say, "Oh, great and powerful keeper of file extensions, I have brought the appropriate sacrifice. I have brought you the empty shell of a snail, $37 in Russian rubles, and according to current market exchange rates, and also one shiny copper pin that was used to hold up a joke in the office of Dennis Ritchie. Please recognize my file extension." And he says, "Your sacrifice is appropriate. You now have this file extension. It shall be written and recorded. So let it be written, so let it be done." This is not the process by which file extensions come into existence. File extensions come into existence because you say, "I think it should be named this," and you do it. And that's how a file extension comes into existence. You'll notice that, again, coming back to video games, you'll notice that many video games like to choose fun and interesting file extensions for their own save files, right? For example, Civilization, Sid Meier's Civilization. You can tell I played that game, right? The save file for Civ 4 is .civ4, right? A lot of the time they'll use .sav, right? .save. It doesn't mean anything. As long as the program recognizes its own file extension and the data is encoded consistently, it doesn't matter what the file extension is. Is that a sufficiently long-winded answer to your question? Okay. Any other questions to which I can offer a sufficiently long-winded explanation? Okay. Yes?
Why would you use WebSockets for this?
Why wouldn't I use WebSockets for this? You want to know something funny? This is the first PHP application I ever developed.
See.
Maybe I'll show you what send move looks like. You'll see it's very much in line with what we've covered in the course so far. It's kind of funny. I think that WebSockets appear in the course description for this course. But to my knowledge, they don't exist in the curriculum of this course. So that's probably something that should be fixed. Sendmove.php. Here we go. So there you go. Using the filtering methods according to how we've done it so far. Don't do that. Right? Basically, there are three inputs that are required to set a value in the grid. You need the X position, the Y position, and the value you're setting. The top half of this is reading the state of the board into memory, same as if we were going to send it to, send it to the client. We do eventually send it to the client as well. But then, just a little if statement, If the position, if the string at that position is already an X or an O, you can't put anything in there. Otherwise, you just do it, right? And then write all of that back into the file and send the updated board. And that's what sendmove does in its entirety. And you can see that, I wouldn't consider this to be an application that had robust security or where robust security was required. But you can see with just a very small amount of PHP, we get a web application that is doing slightly interesting things, right? Like, it doesn't take much on the server to produce interesting effects for clients, right? Does this make sense? Alright. So, let's fire up XAMPP and I'll run you through the functions. I'll run you through. No. XAMPP. Notepad++. Apple is down. Who cares? I don't even know what that means. All I know is number go down bad. Bad for some, good for others. So, just to give us something to work on, the hello world of files on the server is a site visit counter, right? Now this is a problem that may have, like, you know, if before entering this program, or perhaps while you're in this program, you got it into your head, oh, that might be a cool little thing to put on a website. A number of times someone has visited this website counter, right? Impossible from just the client, right? If it's just JavaScript, there's literally no way of doing this, right? So, I know this is like, I don't know, site counters aren't really a thing anymore, you know? It used to be back in the 90s, you very often at the bottom of a website, you'd see a little like ticker thing that showed you how many times the website had been visited.
Then you're the millionth visitor to that website, you claim a prize, and you click on it, you get a virus.
Exactly, yeah. But yeah, no, it was like, you gotta think this is back in the era where, like, you know, every McDonald's had a little thing on its sign saying, like, you know, 52 billion hamburgers sold, you know? This is like, oh, aren't numbers exciting? Yeah. So this is what we will be working towards, is to create a site visit counter in PHP. So, the very first thing we need is the file that contains the data, right? It doesn't have to be complicated. In our case, it's just a single number, right? We initialize it to 0 because nobody has visited the website yet. We then save that 0. XAMPP. There's HTTP. New folder. Call this visits because it literally doesn't matter. Nah. Visits. So, our new object is to read. So, let's make a new PHP script. Save this as sitevisits.php. There we go. Now, of course, you know, there are multiple ways of doing this. the way that we're going to be doing it here, we're going to make the website with a little embedded PHP tag that will tell us how many times the site has been visited. We're going to kind of embed it in a one-page app kind of style. You can also like write a PHP script that just sends that data for use by Ajax, right? An Ajax query in JavaScript sends for this information, and it is sent and perhaps updated at the same time. We're going to do things in a more PHP way here because this is the PHP class, not the JavaScript class. So, PHP. So, we're going to have some code. Then afterwards, we're going to have some HTML. This site has been visited n times. We can set n to be initially 0. There we go. Let's take a look. See if everything's working. Localhost 1080 / 2025-09-4.
You flipped the numbers around. You did 2409 when you saved it.
Oh yeah. Yeah, that checks out. There we go. Site visits.php. This site has been visited 0 times. Just as I suspected. So, now we need to read the file, right? In fact, why don't we just put a 2 in there, just so that it looks different from what we did before, right? So, there are about 5 different ways of doing this from this point. I'm going to start by showing you the classic method of doing this. So this is a way of doing it that will be like strongly cross-platform to other languages that you know how to use. You can, in PHP, and I'm sure in other languages as well, read the file all in one function call, right? But this kind of like doesn't suit my educational purpose in this classroom, which at least partially is to show you what a file stream is, right? So, file streams, right? To read a file, or to write to a file, we open a file stream. The file stream, you can think of it as an object containing all of the information necessary to read to the file, right? It contains lots of information. What file are we talking about, right? When was it opened? But most importantly, the reason it's called a file stream is that you can think of it as having a cursor, right? There's a point that you are at in the file at all times when you have a file stream open, right? So when you are reading from a file, you have operations like read the next line, right? It doesn't make sense to read the next line unless you know what the next line is. To know what the next line is, you must know what the current line is. Therefore, you need something to keep track of the current line. That is called the file stream. Does that make sense? Some languages also call them file handles or file handler. These are all synonyms. All right? So, the functions I'm going to show you are basically more or less direct, a direct exposure of the C standard library, which is why these functions, you'll find them pretty much everywhere you look, right? Because these are in the gosh darn kernel. So, to open a file, fopen. That stands for File Open. fopen requires two arguments. Number one, the name of the file that you are opening. Number two, the mode you are opening it in. In our case, it's visits.visits. That's the name of the file we're opening. Mode is somewhat interesting. There are three modes that are kind of primary importance to us, but there are there's a very large number of modes, most of which you'll never ever use, some of which you may use very, very, very occasionally, but it only really makes sense for us here to talk about three of them, all right? Read, write, and append, right? Why do we have both write and append?
When you use write, it is on one syntax constantly.
Precisely so. Write means overwrite, right? So write mode will destroy everything that was in the file before you opened it for writing. Actually, I think it only actually does that if you perform at least one write operation on it. I could be wrong about that. I'm pretty sure. Like if you just open it in write mode and then immediately close it without actually doing anything to it, I'm pretty sure it doesn't actually like overwrite file or blow anything out. But if you write anything into the file, it destroys everything that's already in the file for you to be able to put stuff in. Okay? Make sense? So that's what append mode is for. If you want to add to the end of a file, open in append mode. Just like appending to an array. Make sense? Good, good. All right. So, in our case, let's just open it in read mode. It's a little strange, but this is for reasons that this is for C standard library reasons. The way that you tell it what mode it's to open a file in is by providing a single character string as the second argument. R for read, W for write, A for append. Again, there are lots of different other ones, but let's just focus on those ones. So, the return result of the fopen command is a file handle object. This file handle object will be necessary in all other file functions that we are going to use. So we need to save it to a variable. With me so far? Good, good, good? This making sense? All right. It's similar to, but not quite the same thing as, the scanner object in Java. But it's kind of similar in concept, right? So, one thing that is very, 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 very important when you are opening files in this way is to remember to close them. All right? This is often overlooked, but it's very important. When you have file handles that make it into the garbage collector, in these sorts of languages, the file will be closed as the file handle is deallocated. But that doesn't liberate you from the responsibility of remembering to close the file yourself. The fclose command, when passed a file handle as an argument, closes the file. So what does it mean to have a file open, and what does it mean to have a file closed? Right? This starts to become operating system stuff. Right? The operating system keeps track of what processes have which files open. And it does this for good reason. Have any of you heard of race conditions? Can you describe a race condition to me?
So basically you have two processes doing something, and then let's say they're trying to output to the same file. Depending on which process finishes first, you'll get a different result.
Yes, very good. So I'm going to do this one on the board. There we go. All right. Let's see. So let's say you have two users. User A, user B. They come from the planet Lexicon, and they are people who have letters for faces. That's canon. Let's say that person A and person B are both interested in writing to, specifically writing to, file C. Race conditions do not occur when all you're trying to do is read the file. If all you're doing is reading the file, as many people can read a file as they want simultaneously, right? Because the file itself is not being modified. Although it's still, well, as we'll see, things can still get a little weird. So let's say that we have a timeline. First in this timeline, person A opens a copy of file C. So they have file C. Then person B opens a copy of file C. Both person A and person B have a copy. Sure. Let's also assume that the operating system is doing nothing to prevent the imminent disaster. All right? Let's say that person C labors very hard to produce changes to the document. We'll call the new document person A produces document CA, the A version of C. Let's imagine that person B undertakes a similar process, produces a copy CB, but most interestingly, finishes before person A. What happens when these people try to write their changes back to the original file? If CB goes first, then the state of the file here is CB. If person A then comes along, this is open, this is open, this is right, this is right. Let's say that person CA then comes along, writes their changes into the file. So down here, CB's work is overwritten. At this point, it is most probable that this copy of CB has been deleted because it was only in temporary memory to begin with, right? So, this is what's known as a race condition, except unlike a normal race where the fastest person wins, this is a reverse race where the slowest person wins, right? Whoever takes the longest to write the file back in wins the race, has their changes kept, whereas the other person's changes are obliterated. Right? Does that make sense? So, this has applications, right? within the context of one operating system, we can solve this problem with a thing called a mutex. Mutex stands for mutual exclusion. So basically, the way that this process gets modified, when person A opens the file for modification, they then lock the file until they're finished with it, right? This prevents person B from opening the file while someone else has it open for writing. Because they couldn't open it in the first place, they couldn't produce their changes, which means those changes could not have been overwritten, right? Basically, you knock out the initial step in this unfortunate chain of events. When person A closes the file, that releases the lock on the file, not when they're finished writing, right? The computer has no idea when you're finished writing. It can't predict your next statement. That's an interesting thing. If you hadn't realized that by now, like that's something worth running through your noodle a couple of times. Like the program, when you're programming in any programming language, the program itself has basically no ability to predict what the next statement it contains is, right? It would need that to say, oh, I'm not going to be doing any more writing, right? I can see the rest of the program. I can see I'm not doing any more write operations, so you can release the lock now. It's like, no, that's not. It doesn't know how to do that because programs are convoluted and very tricky and suffer from a mathematical problem called the halting problem, where it's actually impossible. It's even impossible to write a program that can understand whether a program is going to terminate. That's called the halting problem. It's an unsolvable problem in computing. You can't write a program that knows if another program will finish, right? So you certainly can't write a program that will know if another program is finished writing to a file, right? So how do we solve this problem? We make it your job. We make it your job to close your stupid files when you're finished with them, all right? When you close the file, you release the resource back to the operating system, and the next person who wants to use it may then use it. Make sense? Any questions? You may think that this might be, this may be of only passing importance when you're talking about your own personal computer with only one user. But when we are talking about a server, which is servicing requests from hundreds, thousands, tens of thousands, trillions of billions of users simultaneously, this starts to become an actual real hazard, right? So, I'm pretty sure that that was where the undefined was coming from in the tic-tac-toe game that you guys were able to produce. It was either you caught it in the middle of resetting the file, or if two events happen within, I don't know. I'm not sure where that comes from exactly, but this is related to where it comes from. So yeah, does that make sense? So close your files, yeah? Okay? Either close your files or use a function that automatically closes the file. When you use a function like fgetFile, which is the one that reads the entire file contents all in one go, it has fclose built in, so you don't have to do it explicitly. But if you're doing it using the C standard library way of doing things, then you do have to remember to do that. Make sense? Y'all are too used to languages with garbage collection. That's what I say. So, so we have opened a file, we have closed the file, but we've not done anything with the file. We have opened it in read mode, so we should read from it. There are two functions you can use at this point to do that. Get s. File get string. Accepts a file pointer. I do. There we go. That was freaky. Accepts the file pointer. Produces as its output one line from the file as a string. For our purposes, we will now echo the line which we read. Ah! There we go. So you can see the value 2 has come through. Very good. There is a variant that allows you to read character by character as well, fgetc. Often, line at a time is, you're basically normally either writing or reading one line at a time or everything. So, does that make sense? So, fgetS reads one line out of the file. It then advances the file pointer to the next line in the file, so that the next time you call the same function, fgetS, you get the next line out of the file. So, let me just modify this so that it has maybe a bit more data in it. 3, 4, 5, 6, 7, 8. There we go. If I repeat this a couple times, reload, you can see on subsequent fgetS operations, I'm reading each of the different lines of the file in sequence. Does this make sense? Hopefully this makes sense. Any questions about that? So, okay, sure, we can do it multiple times. But like, do we like doing that?
Could you do it for a loop or something?
We should do it in a loop or something? If not a for loop, then some other kind of loop? Yeah. Yes. This bad. Don't do this. If you find yourself doing this, you should think to yourself, I should be doing a loop. Right? But the question is, how do we write the conditions for the loop? Because we don't necessarily know how many lines there are in the file going into it.
is there something that like reads the stream that just says keep going until you run out of lines?
As a matter of fact, that is precisely what there is. You have very good intuition. So, we don't use for loop here though.
It'd be
This-
wild lines.
Yeah, this is one of those interesting occasions where the while loop, which, you know, has been, like, let's face it, the humble while loop has definitely been shown up by its flashy cousin, the for loop, in like 99% of cases so far, right? But the while loop is more flexible. You can do stuff like this. While not f end of file. File handle. There you go. So, FEOF is a function returning a Boolean result. It returns true if the file pointer has reached the end of the file, and it returns false if it hasn't. My loop is stating, so long as the file pointer has not reached the end of the file, continue reading lines out of it. Make sense? Good. Any questions? This stuff is fairly straightforward then? Okay. So, all right. I'll show you a couple more things. There's one other thing I'd like to show you about reading. So, there are absolutely, like, one of the old and traditional debates that I have about files and reading files. People tend to overemphasize the one function file read, right? It's like, oh, why would I call all of these things if I have a function which just reads the whole file, right? Well, it really depends on the structure of the file. If you're going to have to loop through every line and do something anyways, it makes sense to read one line out of the file at a time. Another consideration is memory, right? If you're only reading one line out of the file at a time, you only have to hold one line out of the file in memory at a time. In a server environment where very often we are being directly charged money for our system resources, using constructs which result in fewer resources being used will save you money, right? More efficient programming becomes more financially efficient programming, right? Now, you might say, surely the amount of RAM I'm talking about here would be inconsequential. And the answer to that basically, while the amount of memory the amount of extra memory it takes to read the whole file might be inconsequential for one user, you have to multiply that by the number of users that you have requiring that resource, right? Like, you have to bear in mind scalability, right? You may have a large number of users. Like, if you have, for example, let's be optimistic and say you have 1,000 users connecting simultaneously, running a script, right? If you are wasting, if you're reading a file that's, let's say it's 10 kilobytes, right? If you're reading a file that's 10 kilobytes, and like each of the lines you could get away with like, you know, a couple of hundred bytes, right? Each line is a couple of hundred bytes, but the file in total is like 10 kilobytes, right? If you load the whole file in, right, you still approximately have 10 kilobytes being used when it doesn't need to be, because the size of the 100 bytes is small in comparison. Multiply that by 1,000 users, right? And suddenly you're not talking about 10 kilobytes, you're talking about 10 megabytes, right? That's significantly more, right? And if you're, you know, that problem scales with the popularity of your application, right? Does that make sense? So basically, once again, like I'm not saying that like, you know, things can never be convenient, you know. Sometimes that's exactly what you need to do. There are applications, absolutely applications, where reading one line at a time isn't what you want to do. Can anybody think of one? When is a file structured so that individual lines aren't that interesting or important? JSON, right? When you're reading a JSON file, white space, first of all, doesn't have to exist in the first place. So, like, when a machine will generate JSON, it generally puts it all on one line, much of the time. So, like, there's no difference between reading the whole file and reading one line anyways. But even if it's been nicely broken down, reading JSON one line at a time is murdersome, as in it makes you want to murder people. The way that you do JSON is you load the whole thing up into a string and you decode it so that you get the data structure out of it. Hopefully the JSON isn't that big. If you need big JSONs, then you should probably be using Mongo or something like that, right? Something that controls your access to it. So, in that case, if you're reading in a JSON file, I highly recommend the method that reads the whole thing in at once, right? Makes sense to do that. Just, you know, once again, there's no perfect method to anything. Everything has trade-offs, right? And to be a computer's professional means some awareness of the trade-offs of different methods of doing things. Does that make sense? Okay? Have I convinced you? Yeah? So, we'll table this for the time being. fread is an interesting little function. So, fread does not split on new lines. It allows you to read the next n number of bytes out of a file. This means it's fairly easy to make it so that it's reading the whole file contents, right? It's also safe for binary files, but we're not really going to be using binary files. So, once again, you provide your file handle. Then we provide the number of bytes. This is a fantastic way of introducing another interesting file function, file-related function, which is of some use. F size, or is it file size? Yeah, file size. There we go. File size. So file size just gives you the size of the file. It looks up what the file size is from the operating system. And the operating system is supposed to keep track of these sorts of things. So the file size that's returned, if you pass that in as the second argument, then it's saying, you know, I want you to read everything in this file, right? This is kind of like a halfway point between the do it all in one function method and, you know, this is basically how the do it all in one function method works, right? One note on the use of the file size function though, it does not take the file pointer. What it takes is the name of the file you are reading the size of. So in this case, that will be visits.visits. Ah. Semicolon. There you go. Very good. So, we have hard-coded a string. We have now used that hard-coded string twice. Every programmer who's a true programmer in the audience, what are you itching to do? What should we do? What is your life incomplete without? This should bother you. There's a solution. Wow. How long ago did I lose the crowd?
Are you just saying like we can replace all this hard-coded strings with just a variable and just pointing the variable every time you need to use it?
That is precisely what I'm saying. This even counts as configuration data. Highly, highly recommend putting the file name at the top or close to the top and using it as a variable throughout. This way, if it needs to be modified, it only needs to be modified in one place instead of several, where you'll forget half of the places it's been used. Make sense? This is defensive programming. So, does this make sense? The alternative to this is to use file get contents. Which, if you're doing this line, this is probably what you meant. Because then you don't have to worry about remembering to close it. Make sense? So far so good? Alright, now, here's the thing though, alright? Here's a what if scenario for you. What if I had a little sneaky something like this? You think semicolon. There you go. Remember that in PHP, the text that you write is interpreted in terms of HTML. The file might contain a script attack. Now, you might think this a little strange. You might think this a little odd. Why on earth would a file I made on the server contain a script attack? Why? Why would that be the case? Surely this is a thing that wouldn't actually happen. Well, this is actually a whole category of attack called stored XSS attacks. Let me spin you a little yarn. Let's imagine that we have a comment system. Let's say that we have comments left on, products for sale at Crazy Sam's Spring Company, right? Let's say that this website for Crazy Sam's Spring Company was coded by Crazy Sam's 13-year-old nephew who knows computers really well, right? And has no formal education and therefore has no idea what security vulnerabilities mean. So, allows people to write things into files without filtering them first, right? The point of entry of all of these things is always someone didn't filter something properly, right? So let's assume that unfiltered user input is being stored by the server somewhere. Much of the time this will be in an SQL database or something of that nature. But if the data in the file originates with the user in any way, shape, or form, it is possible that the user is sneaking in scripting attacks in this manner, right? So stored XSS attacks are far, far more serious than the type that we've talked about so far. The hypothetical, bad stinky email link that you shouldn't click at all because it looks so suspicious, right? That is called a reflected XSS attack. The attack itself is contained in the link. You execute the attack by clicking on the link, right? So in a sense, they sent the attack at you and you reflected it, right? You sent it to your own, browser to be executed. In the case of a stored XSS attack, the attack is loaded by anybody who loads the file containing the attack. This means it does not require any particular condemnable action on the part of the user to suffer the attack, right? You don't have to have done anything wrong to get attacked. The attack didn't come from you. It didn't come from you clicking on a bad, stinky email phishing link, right? It was just on the server. Everybody who visits a page which loads that data and displays it gets the attack, right? Does that make sense? That's the difference. So that's why stored attacks are much more serious. When you are doing a phishing attack, you're getting at most every poor grandmother who clicks on your stupid phishing link, right? With one of these, you are getting literally everyone who visits the page. So it's like it's kind of like a one-to-one versus like a one-to-many type of thing, right? So, does that make sense? It's a very bad thing. It's a very, very, very bad thing to be avoided at all costs. Fortunately, there are ways we can deal with this, right? very simple. The way that we filter this is the same way that we filter inputs which are coming from the user. We use a slightly different function though. Instead of filter input, which presumes that the value we're filtering is in one of the input superglobals, we have filter, no cap locks, filter var. Filter var. Filter var takes just a good old honest ordinary variable and it applies filter sanitize special chars or whatever you have, whichever one is appropriate to your situation, but filter var uses the same set of filters as filter input, right? You filter things in the same manner. All it does is it applies it to a variable instead of the superglobal. Make sense? And as with filter input, the filtered output is given as the return result of that function. So, you reload and there you go, a filtered tab. Any questions? Does this make sense? So, you may be saying to yourself, okay, sure, but if I'm properly sanitizing all of the user input that's coming from the user, shouldn't this be unnecessary, right? Should I not be able to rely on my previous layer of security and not worry about it past that point, right? Because that's a reasonable thing to do. We want to minimize redundancy, right? Well, you should always think of security in terms of layers of security, right? You should always attempt to have multiple layers of security, not just one that you put all of your faith in, right? It's, yeah, sure, okay, maybe maybe that's true. Maybe it's true that if you filter all of your information that's coming from users, no bad data can get in, you're safe, everything's fine. But you are making an assumption, right? You're assuming that you understand the situation perfectly. You're assuming that, you're assuming that the first layer of defense is in fact impermeable, which is, perhaps an assumption. You're assuming that you're working with, the people you work with all value security as much as you do, right? Vulnerabilities in code are normally introduced by the developers who code it, right? You are unlikely in sufficiently large projects to be the only person working on a project, so perhaps it's not just the user that you should try to trust less, but your own colleagues, right? Not that your colleagues aren't wonderful people, but it's kind of like that same question of why ever make variables private, right? It's to protect the system from abuse by people who, either don't understand what you're trying to accomplish or think they can do something clever, right? Unfortunately, many programmers think of themselves as being clever and will try clever things they think are clever, but which just tend to introduce, bugs and security flaws. So, yeah, make sense? Any questions? Okay. This is supposed to be a site counter, so let's go over how to write the data as well as read the data. I will fix this file so that it's back to rights. There we go. Give that a 0. So in this case, since it's a site counter, what we're actually looking for here is filter validate int, right? We expect the contents of the file to be an integer. We should therefore check to see that it's an integer. If n is equal to null or n is equal to false, echo bad file, bad file, bad, exit 0, just like that. Get rid of that too. So, we wish to take the number and increase it by 1. There we go. Now, we need to write that variable into our file. We open the file, F-O-N in write mode. So if fread is the function we use to read data, who wants to guess what the function we use to write data is? Anybody?
Right?
Yes, it's fwrite. So fwrite, it's a little interesting in comparison to read. It functions a bit more like fgetS in the sense that if you call fwrite multiple times, it will continue appending to the file, right? So you can write multiple lines in using fwrite, but you can also like write the whole thing as one big string in using fwrite as well. So fwrite kind of does both jobs in one function in comparison to reading where we had 2 different functions to do those 2 different jobs. Does that make sense? Yeah, okay. So if we fwrite n, and then what do we always remember to do? We close it. There you go. So now, fwrite expects 2 parameters. Uh-oh. Okay, what is the next one? Oh, I'm sorry. The first one's the file handle. The second one is the thing you're writing into it. Pardonnez-moi. Oh. Yeah. Let's see here. One. Oh. But this should be n. 3, 4, 5, 6, 7. There we go! Yay! If we take a look at the file, it needs to be reloaded. You can see that the state of the file is changing as we execute the script. Make sense?
I actually think it's kind of cute that back in the day a bunch of websites had this, because it's like this is a very simple thing that we've learned. And then you have these websites who had this as well. It's kind of like everyone was kind of just like figuring out how code worked as it went on.
Oh, it was great, yeah. Oh man. Those were the days. Let me see, site counter from the 90s. See if we can find one. Get out of here, you. Yes, this is the type of thing that you would often have, right? this particular style in particular, right? Oh, you were always visitor number one. Ha ha ha, yeah, yeah, yeah. Cute. Cute. This is the type that you'd see quite frequently though. And they have like the thing to make it look like a drum read number thing, you know? But yeah, yeah, it was a different era, you know? Like back then, you kind of like there was no such thing as a blog, right? The closest thing you could think of it was like I've written a pamphlet, you know, and I've put my pamphlet up, and look, it has pictures in it, and look, the pictures take literally 4 or 5 minutes to load, you know? Man, I probably have told this story before, but like I remember fondly one day in my youth, right? I grew up in the 90s, and as some of you may know, and I played the Pokemon, right? But this was like pre-internet Pokemon. Post-internet Pokemon sucks, because it's like there's no mystery anymore. You know?
I was thinking that you remember like the old like schoolyard tales of like how to get to Missing No or the Mew under the truck or whatever.
Yeah.
Now it's just all online.
Yeah, it's like it's ruined everything. The internet's ruined everything. But like back in the day, it was like someone had to show you the rare candy cheat. You know, someone it's like, oh, did you know that there's actually 151 Pokemon? And it's like, no, I've never seen. You're lying. And it's like, they only gave it out in Japan. And it's like, we don't live in Japan. We can't possibly verify this, you know. But you know, I like one of the things that you could do is you could there was like a website, and the whole purpose of the website is that it contained a picture of every single Pokemon. And it's like most of them had the wrong name, right? They were calling the Pokemon the wrong names on this website. But I remember I spent like an afternoon just loading those images, right? It's like, because you'd have fun, because like you'd scroll to the bottom of the page, see if any new ones came in. And it's, oh, look at that. Then you scroll back to the top of the page to see if any ones came in up there, you know? And it's like, it was fun, but you know.
Was your modem 28.8 or 56.6K?
Oh, you shouldn't ask me that. I was like 8. I don't know.
You heard the modem sounds though, right?
Oh yeah. Oh yeah.
I
Yeah.
don't dial-up.
Oh man.
Get off the computer, I'm expecting a phone call this afternoon.
Yeah, get off the computer. I'm expecting a phone call. Yeah, absolutely. Goodness. You guys don't know how good you have it. All right. Databases? Yeah, shall we go to databases? All right.
It's also glorious. Fondly remember going on LimeWire and downloading like the newest remix from EXE and getting like a new tweet.
Oh wait, I gotta turn that off.